Welcome to another Sumobot meeting. Today we're going to go over just basically putting all of your code together. So you've already learned how to do your motors, you've already learned how to work with your sensors, and now it's just putting it all together in some code. So to start it off, I have in the Google Drive that we all know how to get access to, I've put a beautiful PDF. Tutorial 6 is what we're on right now. So I have here basic Sumobot algorithms, and it just has a couple of things that I will review in the next few minutes. Some useful info and just quick reminders of what everything is and this different, why do we do these things. It's pretty simple, but it'll help. Specifically these beautiful little block diagram things that I'll explain later. And then there's 2 zip files. I'm going to be working from this version, the not filled in code, and I'm going to be taking, I guess, I'll be taking this code and filling it out over the next hour or so. And by the end, you should have something possibly better than filled in code version. I actually haven't looked at it in recent months. I don't think it was the best code in the world, but I think it worked for what I was coding it for. And of course, my code won't work identically to your Sumobot because you'll be using different inputs. You'll be possibly using slightly different sensors. Your motors might run a little fast. You might want to slow them down and whatnot. And there's tweaking. So once you download the code, you'll have basically this. I'll zoom in a bit more here because I know high resolution screens don't show up so well in compressed video. So we can see here there's a few different functions that are blank. We have check edge, turn around, stop, go forward, go backwards. And when we have our void setup and our void loop, which you probably at this point is quite used to. Usually it's quite common when coding C applications, you put the, if you just need a quick function of some sort, you put it at the beginning of the code, right at the top. These would all be considered, I guess, quick functions. And you just put them at the top, and then you void setup and your void loop. So your main function kind of goes below. That's just kind of for making your code look better. It's just kind of standard. I don't think, don't quote me on this, I think C will throw an error if you put it below your main function. I don't think so, though. I think that's only, I'm pretty sure that's only a Python and interpreted language issue. So, to start it off, I need to run some debug because I left off what I was doing. I guess, in the Q&A tutorial, people were asking questions and whatnot. I was working on my Sumobot, and one of the things I was doing was trying to test. I was trying to test my edge sensors because I didn't know which one coordinated to which input, and I also didn't know if when I put the sensors onto white or black, was that a 1 or a 0? So last time I wrote some code, actually, and I have it already programmed, but I ran out of time. So I'm just going to show you guys that here running for those curious. And all I have to really do is, since it's already programmed, all I have to do is plug it in. And it should just start spitting out data, I hope. Yeah, there we go. So you see 4. That's basically it's showing how many sensors are triggered right now. So if I was to put this on the white, oh, cool, almost there. It should go to 0. So see, now it's on the white, and that confirms that. Basically, the sensors get triggered, or they'll toss out a 1 based on how this code is working. It'll toss out a 1 if it's seeing a dark color, and if it's seeing a light color, it'll toss out a 0. Kind of, I guess, backwards. You'd expect more light equals, more higher number, but so we can see that from the code and then put it over and then all 4 get triggered. That is quite accurate. And then if we put only the front 2 on, we get a value of 2. And I don't really care which sensor is which in this case. This test is really just to see how many sensors are getting triggered. 3, 2, 1, and then 0. If you do some kind of test with edge sensors or the LED and photoresistor method, I'd recommend using some kind of matte surface like a tissue, a piece of paper, paper towel, and same for your dark surface as well. So I'm just using my desk, which is a little bit reflective, but a matte surface is way better. So off the top of my head, a piece of fabric. A bad example would be like an iPad screen of some sort, or the fingerprints. But this, for testing, like first of all, it doesn't match the actual Sumobot surface. The Sumobot surface is quite textured. So what it this is quite reflective, and it'll basically, I think it'll still show. I think it'll show a 0 if I do this, right? Let's see what happens. Yeah, see, it thinks it's white when I put that on, which is not what we want. So just hot tip, if you're trying to debug, use a matte black surface. So that's just to show the code and confirm some of my theories so I can write my code better. So we'll just close that and actually try and write some of the code. And of course, to write some of the code, I need to base some of my assumptions off of the PDF. So I provided a little bit of info on what's going on here when it comes to these edge sensors, because they might still be a little bit confusing. So I did a little couple doodles here. You can see this is the edge sensor, so this is what I'm using, and then there's also the photoresistor. So you can see it sends out a little pulse and then it tries to detect it. It's an infrared pulse in this case, and it'll output a 1 or a 0. That's what's going on, is it's reflecting off of the surface. And the same with an edge or your photoresistor, which you would have, on the bottom of your bot somehow, and you would have an LED. I'd still recommend an LED. From my testing, it might just be the best choice. Give you better results all around, but you might be able to sneak by without it. I think the main issue, you would need to have your Sumobot kind of riding high, I guess, because if your Sumobot is way too close to the ground, it'll just be dark underneath all the time without some kind of light source. And of course, the edge sensor has that light source built in. And this is just a quick reminder of what the Sumobot ring actually looks like. I have it on my floor right now. It's basically all black. I want to say it's like 1 meter across. I never measured it. And it has a 2.5 centimeter white ring. So your design should somehow detect a line or an edge with that kind of level of precision. So on to the logic, I guess. There's 2 different ways, of course, of coding. And one of them is without an ultrasonic sensor, and one of them is with. And when I say with an ultrasonic sensor, I'm directly assuming that the ultrasonic sensor is sitting on the front, here, on the front and looking forward at an object. You would have to get a little creative with your code if you wanted to do it on the sides or something of that sort. And another hot tip is to make sure that your ultrasonic sensor isn't bending down and it's about as perpendicular to the surface as you can. Otherwise, the ultrasonic sensor might bounce off of the ground and give you terrible readings. You don't want that. So basically, the way this code works is that you switch on the Sumobot, press a button, and after I kind of skipped a step here. Basically, you switch on the Sumobot. You it does nothing. You press a button, wait 5 seconds, and then it immediately starts moving. So after it starts moving, you got to start running code basically. Basically, what it would be called, I guess, your loop, which is where it does a set of instructions and it comes back to the top and immediately does it again. And you want this loop to just run as fast as humanly possible. So this you can probably squeeze out maybe 200 times a second. At the fastest, I want to say baseless requirement because I've never actually tested it. But it has to take in a ton of inputs, process them, and do some stuff, and you could probably get around 200 times per second, which is faster than you would need. A car's a typical modern traction control system on a car probably operates at 20 times a second, 10 times a second, just for reference. So it'll probably work more faster than you need, but of course it's not like a desktop computer, so you have limits. And I'll show some of the limits later. So once this loop starts running, one of the first things that we need to do is basically go forward. And I'm looking at this now and I see this true here, which does not make any sense to me. But I'm gonna just skip over it. It might make sense to me in a second. Go forward here is basically we're gonna run that command first because we basically just want to go forward. So it's gonna go forward and then it's basically just gonna keep going forward until some kind of edge is detected. Another assumption I'm making with this code is that I only have 2 edge sensors, the front left and the front right. And I'm not using these edge sensors at all down here for this code. So we can see here, edge detected, and if that is true, we're going to stop and we're going to run a turnaround sequence, which will basically just go back up a bit, turn on a dime, which I'll explain more about that in a second, and then just basically go back up and go forward again. Very, very simple, and that's the code I'm going to try and do today. Next week, as part of finalizing the code, I'll also show how to do an ultrasonic sensor and whatnot. So let's start writing the code then. Do you have any questions so far, or?
So far, everything's pretty clear. The diagram makes sense, though. I'm curious to know how the thing turns around when it sees an edge.
Yeah. Okay. We'll be definitely covering that right about now. So. Okay. First things first is to write some code. So we can see here, this is basically this thing here. Let me show this to make it clear. We can see this loop here is right here. We can see go forward, if, check edge, stop, turn around. And these are running the different mini functions that we're going to write.
Yeah, makes sense.
So I'm going to start with checking edge because that is quite simple. And we can also see here I've also provided all of the pin setup because we've done it before. So check edge is as simple as, since we tested it before with that little bit of code, we know we need to basically first of all define a variable, which is going to be our bool edge. Or no, we don't even need to do that. I'm going to make it even simpler. If digital read, and then we're going to read the pin, and we're going to use front left. If digital read front left, so basically if this function equals, since it only returns a 1 or a 0, it makes it quite handy because in C, An if statement will evaluate itself as true if it sees a 1. And
Yeah.
this is basically algebra. This will condense down into a 1. And then inside of these brackets, if that's a 1, it'll continue to the next line. Since we know a 1 is not an edge, actually, we actually need to add an exclamation point, which will invert. If it sees a 0, it'll just see a 1, and vice versa. So now we want to actually continue down into this line. We need to add a little brackets here. Now it's like, oh no, an edge has been detected on front left. What do we do? Well, we want to say, well, we found an edge. That's a case for finding an edge. So we'll do return true. And what's that basically saying? It'll basically go back out. It'll back out of the function and immediately backs out. And then we'll basically go into here and be like, well, now a check edge is now true. And we'll immediately jump into this function. It won't run this function unless this is evaluated to true. That's what's happening. And of course, we need to add another case, so an else. If. Same thing, except we just need to change from front left to front right. And just confirming, yes, front right. And then we just do the same thing. We can make it even more fancy by just adding a simple or, because it's technically either or. This really goes to show just how versatile the C code is. I can actually do that right here. Here's one version, and then we can even write it like if this here or that, and then we can just do the brackets for return true. And of course, up here I forgot true, but they will basically function the same. And there is the edge detector.
Yeah, that makes sense, but can you say again why you said not? So why we need to negate the result that we got?
So remember back to the test that I just did. If the Sumobot here was on black, which means it's not an edge because our Sumobot ring is black on the inside.
Oh, okay.
It was returning ones, basically, or trues from the edge sensors. And we negated it because, well, it's false, actually.
Yeah, because
this is not an edge.
Yeah, that makes sense.
Okay. Great. So now on to the different, oh my god, I skipped go forward, but the different motor functions. This is going to be a lot of copying and pasting. So what I'm going to do here is write basically all of these at once. I'm going to write one, and it's as simple as copying and pasting, changing a couple values. To make our lives easier, you can even go back into the old code that we wrote, the motor driver tutorial, and I guess the Tinkercad tutorial as well, all the way back then. So I'm just going to write it off the top of my head. It's going to basically, we need 4 commands. Analog write, because we're controlling 2 motors, and each motor has 2 inputs to the motor controller coming from the Arduino, and then that'll turn out basically, feedback to control 2 motors. So analog write, if I can spell analog correctly. Thanks, syntax highlighting, really saves me there. And then we analog write, and I'm going to write 255, which is the highest value you can write to this, to a pin. And we're just going to do motor A1, and then we're just going to copy and paste that. This is where the copying and pasting begins. Paste that, and then we're just going to change that to 0. Because I don't have it here, but I do have it here. at the bottom, our fancy dancy truth table is, so pin 1, aka motor A1, and then pin 2, motor A2, we need to have a difference for it to go forward or backwards. Pin 1 high, pin 2 low. So in this case, high is any number from 1 to 255, and then low is 0. So we need to have at least one of these 0. And then, of course, we just need to copy and paste this for the next one, which is just motor B. Oops, you know what I forgot? I forgot to add the little 2 there. Motor B2. And then that will also go in allegedly the same direction. I have no way of confirming that because I haven't I haven't checked the direction of these motors. Hopefully it'll go in the right direction, but we'll test it, of course. And it's very simple as tweaking, as like, oh, if one motor is going in the wrong direction, we can just copy and paste that 255 and then change this one to 0. And if both motors are heading in the wrong direction, we can just change, both of them from 255 to 0 and then to 255 here. So let's assume that is the right direction. So we're going to copy and paste this to go backwards now. And all we just need to do is change them up. 255 and 255. And now we need stop, of course. That is the easy one. Could you take a guess on what the values are going to be for all 4 of these?
My intuition just says 0.
Hells yeah, they're all just going to be 0. So that's that. My one thing I'm going to tweak myself, just because I know how this code is going to be used in the future, I'm going to make my go backwards just a bit slower. I'm going to do 128 as kind of like a 50% speed. I know it doesn't, 255 doesn't divide in half like that. It's like 127 and a half, but we're going to use it like that just so it backs up a little slower, because what we're going to use, we're going to actually reuse these functions inside of the turnaround function. So if check edge, stop, and then turn around. And of course, how do we do that? The turnaround code is where we get a little fancy. Because of course we need the motor to turn, or at least we need direction change, not just forward and back. So there's multiple methods to this, as you should probably look here. If both motors spin like this forward, I should stop sharing for this because this is like a little demonstration here. If both motors go forward like that, you get the thing to go forward, right? Both in this direction. Here. Just, yeah, okay. Like such. And then if you want it to go backwards, both motors spin like such. Which works. But now to turn, there's 2 different methods. So if we want to turn to the right, let's just go with for right for now. You can slow down this inside motor, and then it'll make it draw a radius. So this will draw a super tiny circle, and then this will draw a large circle on the ground, and then you would get a turn like such. That's one method for turning, for a right turn. The next method is to just stop this motor outright and then just let this one spin, and it'll spin on its axis of spinning, I guess, will be right on this wheel. It'll basically grind on this wheel and go like such. And then the third version is to make this wheel go in reverse and this wheel go forward. and it will turn like such. And the kind of the turning radius spot will be right in the center of the bot. So this is your kind of tightest turn. It'll do something like this. So I'm going to do something like that for the turnaround method because I need that tight radius. And what I'm going to do is first is I'm going to just, because we're hitting any edge, we don't want to just turn around immediately because we're really close to the edge. So what I'm going to do is I'm going to basically say go backwards a bit for maybe a quarter of a second and then turn around. The exact time that I'll make it turn around for is kind of arbitrary because you don't want it to just go back 180 degrees and follow the same path that it just went down because you won't end up covering the whole playing field. You'll just end up, just covering that one line. And let's say that the other bot is kind of just chilling on the field, not moving, it's broken or something, you'll never push it off. It'll be a draw. So you kind of want it to turn kind of randomly. So it kind of ping pongs off the circle edges. So it's not important to get those numbers accurate. So continuing on with the code, I am going to basically write our go backwards part. And what's important about this function is that we'll actually be using delays. So we're going to say, hey, go backwards. First of all, let's stop and then wait, or sorry, delay, which is in milliseconds. So we'll delay, let's say 200 milliseconds. So it has a time to come to a complete stop. And then we'll go backwards here. Because these commands really, all they do is serve, all these commands serve, these go backwards, go forwards, go stop. All they serve is just to change the direction of the motors, and then the motors will just keep going until they receive another command. They'll just keep spinning. So we'll take that into consideration when we're writing this. So now the motors are going backwards at the state once that code is run. So how long do you want that to happen? And I would say about a quarter second. Let's say maybe let's do 300. It's really arbitrary, I'm going to test it in a bit, see what happens. And now we're going to do our turnaround function. This is going to be where we turn around. So what I'm going to do is I'm going to take this and I am going to modify it. And then we're going to add, of course, a delay function after this turnaround, which will be about, let's say, another 300 milliseconds. So what I'm going to do basically is simply switch the direction of one motor. So hopefully it'll just turn on a dime. And that's the goal of that. And that's, to put it simply, if this code works, that is the Sumobot right there. That is the code in its very, very simplest form.
Wow. It's a lot simpler than I thought.
Yeah, adding the title Sumobot algorithms, it scares people for sure. But here's the fun part, is testing it. The fun part is testing it, tweaking it, making it do the thing that we want. So I'm going to write the code. So of course we got to flash it. Arduino Nano, COM5. You know what I didn't even do? I didn't even add that delay at the beginning. Oh, it's 0.5 seconds, that's correct. Instead of 5 seconds. I'll even I'll readjust my webcam so we can actually see it on the playing field. See, done uploading. Amazing. So the next step is to plug in my batteries and see if I can get it to go. And I need some tweezers. So first, just so when I plug in the battery, the Arduino doesn't immediately want to run, I'm going to remove the jumper here. Let's see, can I get a closer look at? There we go. Closer look at that. There. And man, every day I'm blown away by this camera quality.
It's quite clear.
So let's see. Plug that in. Do not want to reverse the terminals on these batteries. That's no fun. Because unlike consumer electronics, usually the consumer electronics you buy, there's a lot of protections, diodes, MOSs, a lot of protection built in. This doesn't have any of that. You short things, stuff goes crazy.
That's what I'm afraid of when I try making this.
To be honest, stuff will spark likely, but nothing's gonna you have time to react, if anything.
Okay.
So I'm going to shove these batteries in.
Like also the cable management, like understanding the small concepts is fine, but figuring out how to put everything together and to make something cohesive is kind of tough.
Are you talking about like the final Sumobot design?
Yeah, that's what I mean. Like figuring out how to build the overall thing.
Yeah, kind of putting all the pieces together. There's a lot to consider. As you said, cable management for one.
Yeah.
It's already screwing me right now. I'm trying to fit this battery in. Like for me, I deliberately left extra room for wires. If you see in my Sumobot design, there was a lot of holes and stuff I left because I knew wires would be just piping themselves everywhere.
Yeah. Oh, are we also going to have any workshops like this for the winter term?
I'm still deciding on that. I don't know if there's a point exactly on repeating everything all over.
Yeah. I mean, just like covering any new material if there exists any.
It's a very good question. I've been thinking about it a lot. Because there isn't too much more to cover after this. Like I can reduce some topics. I can get into more advanced topics. Might be fun. Like covering the ultrasonic in more depth, trying to actually get like object detection working, which is much easier than you would think.
Yeah, that's what I thought this class was gonna be about. Like having the Sumobot be able to detect actual objects. That's what I thought it's gonna be.
Yeah. So to be honest, I didn't plan for that. Mostly because I know a lot of people weren't exactly. I don't know what. It was hard for me to tell what people were taking on the route in terms of Sumobot design. I definitely will try and do it next week. This isn't a class; it's a workshop. But
oh yeah, workshop is what I mean.
Yeah, if you want to see more about that stuff, that would be good. Like this is a good kind of I guess a middle ground between like actually starting to code your bot and seeing the logic that goes behind it.
Yeah.
Um, but yeah, object detection. We'll do that. Um, so here, now that my batteries are in, I don't know if you guys have ever seen it with all the batteries in, but they're shoved in there, and
Looks very snug.
it is very, very snug. It's pushing out the here a little bit. It's pushing on the trowel a little bit, and it's kind of using it as a spring because the actual 9-volt battery connectors are a little spongy, and that is helping it be wedged in there. And now they won't fall out, and that little ridge back there is helping them stay in. I can't believe how well this first iteration worked. Like I never have first versions of prints and stuff work like that. Oh my. So I am going to, the second I drop this pin in, it's just going to immediately want to.
That's cool.
And oh, oh, that's why a little wire came loose. Damn, that one's why. I have a very small wire. Maybe we can we see it in there? Let's get my light a little closer and bend that up a bit. You can see the pile of engineering in the background. Oh boy.
Wow.
I have a little loose wire right there. And that is powering the Sumobot. Basically, I plugged it in just now, and the red light lit up on this, but no power was going to the Arduino. And I immediately thought, frick, how did that happen? Because when I was earlier, I guess, when I plugged in this to program, the red light turned on over here. So I need to hook that up properly. We're just gonna. I need to, of course. And if you can't see, this is how I'm actually. Like I got some extra wire that I had lying around,
Yeah, I see.
and then just shoved in there, and that is my sturdy connection. As a way to get a really really tight bend on a wire, because I know these DuPont wires do not like to get bent. It's a new screwdriver. I was not expecting doing right now. A little bit risky, screwing around on basically a live circuit because technically there's like 9 volts on here.
Yeah, that doesn't look safe at all.
It's not. um, like the risk is minimal. Like I would have to short 2 screws together, which are covered in plastic, but because I lucked out and I of course removed the little jumper here, which disables most of it. Also, I've become very careful around live batteries because of past experiences.
Yeah, I would have just like taken them out first.
Yeah, but you saw how it took me like 5 minutes.
Yeah, yeah.
So let's see here. Yep, and it turned on. Of course, half a second didn't pass, so I'm lifting it up here because I know the motors are just gonna go wild. And it's up just testing. Aww, they didn't go.
Yeah,
I think
it's
my
not
pinout's
moving.
wrong. think my pinout may be incorrect. Let me see here, because I haven't opened this code in a bit, and I have not adjusted.
So I guess that's the most trial and error part of this, figuring out which pins for what.
A little bit. Specifically, the motor direction is very arbitrary because there's literally not even plus and minus on the the motors. But yeah, you're right. This is part of the trial and error. So what I need to do is, of course, open up. I closed it. My edge sensor test, which since FL front left, front right is 2, 3, which is the same, but our 6, 9, 10, 11. 6, 9, 10, 11. That is correct. Which is great. We have 9 volts. We know that because when we unplug this. It's getting extra spicy here because I can literally see the connections to these motors. And it's not spin. They're not spinning. Let's see. Let's see. Testing maybe my black and white. So I basically what I'm doing right now is I've checked my pins. I set up in my code 6, 9, 10, 11. 6, 9 for one motor, 10, 11 for the other motor. And we can see 6, 9, 10, 11. And oh my god, I figured it out.
What was a mistake?
Okay. So basically, and this is total coincidence, it didn't work either. I'm basically, so remember the keyword I said is 6, 9 for one motor, 10, 11 for the other motor. I have that switched where I have 6 and 10 for one motor and 9 and 11 for the other motor. And as you can see, analog right, 2 of the pins got to be, if 2 of the pins match the other 2 pins, then no motor will spin. So obviously I've hooked it up in such a way where one of the motors is receiving digital right 0 and 0, and the other one's receiving 255 and 255. So all I have to do is switch 2 pins.
The one. Yeah.
And that is quite simple. I just gotta figure out which wires to disconnect. Or I could as simple as just, I could be lazy and just switch the code a little bit. I might do that.
That could work. That's probably faster.
So I'm going to delete all my pinouts and just rewrite them just to double confirm. So 6 is yellow, and that is going to be in 2. So 6, and then 9 is going to go to the other motor's B input. And then 10 is going to red, and that's going to go there. And then 11 is the first one. So all I did was just mess with the define sequence. I know I'm not sharing my screen, but I think you guys can probably figure out that that's what we did. And then I'm just going to upload that. And it's probably going to go immediately. Come on. Yeah, they really played me like that, huh?
I guess there's something else that's wrong.
Yes, there is definitely something else that is wrong. My reliability has been quite high with this stuff too. I think I got a little I got a little cocky with my bot here. It's worked very reliably up until now. Oh, we saw the sensors. The sensors were all plugged in. That confirms that. We saw that working perfectly fine. We see our pinout is now updated and correct. We can see our enables and whatnot. We can see if everything is getting power, that means the grounds are correct because they all share a common ground for power and then therefore signal. If this is getting power, this thing has the 5-volt regulator on it, the 5-volt enable, the 5-volt regulator, which actually supplies power to this. Unless I, in this case, broke my own rule and I plugged this in with the regulator on, but it still worked nonetheless. And it should be commanding those. So, as part of my debugging, I don't want to debug like this because you guys don't have the tools that I have, but I'm going to crack out a multimeter. Very useful tool.
Actually, we're required to get one of those for ECS 1011. So.
Oh, really? Okay.
Yeah.
So everybody has one. Unless you're not in, of course, engineering, but.
Yeah.
There we are. So we have a voltmeter. We can see that it is showing about just 0 volts. The pins are right here. And once we actually put them together, it actually doesn't pick up noise anymore. And it's like, that is in fact 0. It is set to DC, auto. So as a test, I will actually probe the positive and the negative of where the battery is connected to, and I should get just over 9 volts. Just under 9 volts. Gotta play me like that. 8.95, that means these batteries are just starting to lean off in terms of capacity, unfortunately. 8.95 volts, and then we can see over here, we should get 5 volts. 5 volts. It's negative because I have the switch the pins around. And let's see what the motors are getting. The motors should be getting something, but of course they are not. 0, and then on the other motor, 0. A negative voltage or a positive voltage. And this is where we get to test the Arduino itself, and we got to see what voltage is it outputting. So this little blob of solder right here that is hidden beside the zip tie. There's a little blob of solder right here, and that's negative for me. That's negative for everything. The negative of the batteries, the negative of the regulator, the negative of the Arduino, all the grounds connect to that blob of solder. And if I shove a little probe on T9, actually in this case, let's look at motor. Since we should be in the go forward command. If we assume we're in the go forward command. Okay, we're assuming we're in the go forward command, which means we can be sure that motor A1 and motor B1 are set to 255, which means they should be outputting 5 volts. Motor A1, 10 or 11, D10 or D11. And then D11, nothing. If we can see here, we are getting D10. Of course, my hand blocks it. We were getting nothing. It was just 0 volts. It was like showing the same thing. So let's keep that over there. And now I'm going to try let's just see if I look at the 3.3 volt regulator. Oh look, 3.3 volts. We don't actually use the 3.3 volts in this, but that is a test. It's an exposed pin. And our 5 volts is all the way over here. And it obviously 4.5 volts. Now that's a bit sus. Let's see what we're getting over here. Look at that. That's not something to be totally concerned about, but a little bit concerned about.
What's the problem?
So we can see 4.9 volts here. This is right at the 5 volt regulator, basically right there. And then if we go over here and measure V in, sorry, should I be measuring V in? Oh my god, I should be measuring 5 volts because I actually 4.9. Okay, my mistake. I measured the wrong pin. I measured V in instead of 5 volts, and there was a 0.5 volt drop. It was like, crap, something's using a lot of current. But we can see that there. It is not doing so hot. You can see it's I think that's just a bad connection. I'm pretty sure that's just a bad connection. Yeah, just a bad connection. But 4.9 volts, which is for all intents and purposes 5 volts. I'm just going to quickly look at some of my code. Pin mode, digital write, everything is fine, but it is not outputting that 5 volts that I mentioned coming from these, which means our code's wrong, to put it simply. Another method here, I'm just trying to double check. Yeah, 10 or 11 should be outputting something, but they're not. So as part of analog write, doesn't seem analog write. I'm surprised how well this is stumping me. Code isn't running correctly. But the code is so darn simple, as we saw. We can actually show it again. Maybe I should try commenting these out. This is just more like a guarantee that the motor is not going to turn on immediately. What we could do is just comment. There we go. It's the one thing. It might be a little confusing for you guys, but it's just basically forcing everything to be 0 and therefore stopping everything. Because some pins are sometimes booted up as high or 5 volts when you reset the thing. Of course, it's not going to work because I didn't plug it in. So let's quickly plug that in. And nothing happens. Aww. Go forward. There's no compiler errors either, which would be another thing you would check is compiler errors. But of course, since we can upload and we got that confirmation done uploading and we saw the key lights on the Arduino, it should do the fun thing and the motor should spin up. Let's see here. Go forward. What I'm going to do is I'm going to dumb the code down even further. So what I'm going to do is comment this out, and literally just as soon as the motor is connected, just turn it on. Oh, do you know? I figured it
What was it?
out. I mixed up my variables, and it didn't call me out on this. Look up here, digital write. We define what pin number we're using, and then we define the value.
Yeah.
I did the value and then the motor pin.
Oh, so it's like you swap the parameters.
Yeah, I swapped the parameters.
That's so
And
annoying. It should have told you.
yeah, because there's no pin number that is higher than like 16 or something. So, wow, kind of offended, but I'll run with it. That means I need to change all these. No biggie, forever salty, but a fun little adventure game of mixing up the variables.
I feel like a coding bug like this though is much more preferable to there being some type of circuit problem.
The thing is, I'm better with circuits than I am with software.
Really?
Yeah, I do electrical engineering.
Yeah.
So circuits, I would rather. Yeah.
Yeah.
Currently, I'm working on a satellite. I'm building like a little satellite with some other people. Um, I know I'm literally doing rocket science on the side. Super fun, but of course, I would much rather the software mess up because that means it's not my problem.
Oh yeah.
That's a case on the other side. But if something goes wrong, I know how to fix it circuit wise because I know them like the back of my hand. A1, A2, B1, B2.
It's pretty much exactly the opposite in my case. I don't know anything about circuits, but I know how to code.
Are you computer or software?
I'm in computer engineering, so I will learn about circuits eventually, but I used to be in computer science.
Hmm.
So I know Python. C looks really similar in a way. But yeah.
I think the difference is C is weakly typed and Python is strongly typed. I think that's the difference.
What does
No,
weakly and strongly mean?
like the format. I think. Don't quote me on this, but this is from what I remember from way back. Strongly, excuse me. Strongly typed is when like the format of the code, the tabs and the colons and everything has to be in a very specific spot. With
Yeah.
Python, as you know,
Yeah.
you have indentation errors. Weakly typed being C, where I can just add a white space. I can
And that's fine.
I can
Yeah.
tab my code and it doesn't care.
Yeah.
As long as it's within the brackets, there's a semicolon, and life's good. Like if I wanted to write everything on one line, I could.
Yeah, you
Oops,
can't
I
do that
blamed
on
buddy.
Python.
Yeah, so that's like the main difference. Okay, everything here is working. I am just going to one more edit. We're going to change that to 0 and 255. We know for a fact that this is not messing with us. And now we're just going to keep it simple. And I am going to keep these off the ground because stuff will get wild. Uploading, and it takes good time. Hey, it is working.
Yes, I hear the sounds. It is
Yeah.
moving.
But here's the thing. I don't know how to shut it up.
But it lives.
It does live. The issue is that it's constantly detecting an edge, per se. I'm basically holding down. It is very fast. I have no way of shutting it up. Give me a moment. I'll figure it out. Okay, unplug the Arduino. That is my only way of shutting mine up. But it was always detecting an edge, and it was always doing the check edge stop turn around thing. Constantly. Which is a little bit annoying.
So how would you stop that?
I am going to try and figure that out. First, I'm going to change these so it's less confusing for you guys. It's just digital right now. I'm just writing them all to zeros. Just analog. So we know from our previous code that our edge sensors were working. Of course. Hold on. I'm just going to try and run this code again. This is more of a connection test here. So we can see as soon as I put it on the ground, 4, right? And then as soon as I put it on the white, 0. Very well tuned circuit, not gonna lie. So you can see digital read, front left edge, front right edge. Basically, I was holding it like just like this. I just had one finger up, and I was trying to see what direction the motors kind of wanted to do. Oh, you know what I forgot? I forgot the else statement. I don't have an else. Return false, basically. Return false. I don't exactly. If there's no return, I don't remember what it will return to this function. It might return just a true as a default.
Oh.
So
But wait, how would it reach the else statement? Like what condition would have to be true for that for it to reach the else?
Basically, no edges detected. There we go. Can you hear it?
Yeah.
And then as soon as I put it on the white.
Cool.
Oh man. Okay. I am going to try it on the platform for I think the first time ever. Okay, guys, it's gonna happen. We wrote the code. I know since a lot of you guys don't have a Sumobot actually working at this point, you guys probably want to see this.
Yeah.
So I am going to. This is an amazingly just in the middle of my floor on my bedroom floor. It's gonna be amazing. Okay. And raise this up.
So that's the stage that the competition is going to be on, right? And then you just place the robot.
Yeah, so let me adjust my autofocus points here because they're dumb. It doesn't want to focus. Focus. There we are. Does that look a little grainy or?
No, it's pretty clear. We can't see the full circle, but it's clear.
I can't raise my tripod up enough, and this is
Yeah,
not a
it's fine.
zoom lens since it's a macro lens. So
We can see most of it.
okay. Okay. Oh gosh. Okay, you can still hear me from here, right?
Yeah.
Sumobot, amazing. It's gonna be great, and all I'm gonna do is just plug it in, and it will go on. If it doesn't unplug itself.
Oh my god. That jump scared me.
And it was really freaking quick. Holy crap.
Yeah.
And of course, it immediately just. It has some drifting issues. But it does detect the edges. Okay. Okay. That was a good first test. The main issue is that it drifts a lot. Okay, now shut up. Okay. The main issue is that it drifts a lot. Which is actually a flaw in my design, I guess. So we can see here. Here we are. On the bottom of my Sumobot, right where the wheels are, there is some depth. Damn, I'm all disoriented.
Yeah, I see it.
See, that is really close to that height-wise.
And that's a problem?
You can see it there. The
Yeah.
bolt is just... So it's not getting the best kind of straddle on the ground. Not too hard for me to adjust. I can just replace it with our Lord and Savior hot glue. So that's a flaw that I have to fix for my own bot design. But the other thing is that it was moving wicked fast, to a point where it just, like, by the time it detected the edge, it was already off the edge of the table, or off the platform. So it needs to move slower. So I need to drop all the speeds down. Even like when it was backing up, it was pretty fast. So it needs to dial it down. And these are also with like almost like on their way out, like I would say 50%, 60% capacity batteries based on that voltage that I was reading. So let's fix that.
I mean, those are good problems to have because it's just numbers that you gotta change, right?
That is true, yes. And I just looked at the time. We've been going for an hour and a half, so I think we should leave it there. But that is it. I don't even know where I don't have one of those fancy cameras with the tilty flippy display, so it sometimes messes up. But that there is the tutorial. I hope you learned something.
Yeah.
The code is a lot simpler than you would think.
The code was the coolest part. The code is really cool. Like, it's amazing how it can do so much with something so simple.
Not to be controversial, but I think the circuit was the best. But I'm glad you found the code interesting. Yeah, it's really simple, and we can simplify it further all day long. And you can also make it more complicated, which I encourage you to do. Add more functionality.
Yeah. So
I'm going to replace, I guess. Once I edit these numbers, I will replace the zip folder. Where is it? Where's my Google Drive? There it is. I will replace this filled-in code with this new one. Just so you have it.
Yeah.
But I definitely challenge you to just work off of the not filled in kind of thing. Gives you more of an achievement. Anyways, do you have any more questions regarding this?
I think it's pretty clear. The motors workshop I need to look that over. But I think once I understand that and Fusion 360, I think everything's pretty clear.
Okay, that's great. And I guess I should say to everybody, we are open to 3D printing your stuff. Just send us the file through that link. I'd recommend telling us once you fill out the form. I don't know if the email response is working correctly. So I don't think we have any idea if you submitted it because we don't check the form itself constantly. And if you're looking just to experiment, let's say your print is kind of like you're not sure if it'll work. Like for one, we can check it, but even then, we might just print it for you just so you can see in real life did it work and why didn't it work, and you can see with your own two eyes why it didn't work, and we'll reprint no problem. And and of course, exactly how you pick up the prints will be up to I guess a conversation between you and me, be it picking up from York or taking a bus ride down to where the 3D printers are actually, which is really close to York. Um, so yeah, I think that's it. Um, and we'll see you next week.